Let's keep doing some example questions. Okay, have a read of this question here. Okay, now a small truck of 3 tons collide with a stationary car mass of 1 ton. So we have two objects, we have a collision. Okay, so now write it down. Let's put it down. Mass 1 is 3,000 kilogram. Okay, mass 2 is going to be 1,000 kilogram. Okay. They remained locked together afterwards as they move on. Okay, so the speed. So what's happened is the speed after the collision is to be this. So now let's after. Okay, so m1 plus m2 has a speed of 7 meters per second. Write the information down. Now from the that's down. Robin, one of the police investigators investigating the crash, use this to estimate the speed of truck before the collision. Now, here is a trick question in exam. Okay, now because in the exam it says use the conservation of momentum, so we have to mention it. So momentum before must be equals to the momentum after. Okay, so just let me write down clearly. So the momentum before equals to the momentum after. Okay, now let's write it down. Okay, so we need to find the speed of the truck before the collision. Okay, now name it V1. Okay, so M1 times V1 plus M2 times V2, okay, which is V2 is stationary. Okay, that's the total momentum before equals to the momentum afterwards, which is M1 plus M2 because they've been locked together. Okay, times afterwards let me give it a name. Okay, V2 after V2A. Okay, V2A times V2A. Okay, so put down all the numbers in. 3000 V1 plus, because it's stationary, V2 will be 0, so it will be 0. So 3000 plus 1000 times 7. Then just do the math. So times 7, 4, 7 is 28. So 28,000. Now we can cross, just do the math. 28 on 3. Use your calculator or do it by hand. It's going to be 9.3. Two significant figures, meters per second, 9.33. Okay. Two significant figures. Okay. Now, yes. Okay. In the exam, how they mark the question? Because in the exam, you get 1 mark to mention this. Okay. You get another mark to write down the formula. You get another mark for the right answer. Okay. Now, normally you don't have to mention that, but sometimes, because it says use the conservation of momentum. Okay. So you need to include that here. Okay. That's the conservation of momentum. then if you don't, even you have the right answer, the examiner could take marks off. Okay. Now let's go to the next question. Question 6. Okay, so what's happening is we have space shuttle docking with the International Space Station. Imagine you are an astronaut flying in space at rest. Okay? Now relatively, so initially your V will be 0 at rest. Okay. Now then you watch the space shuttle of mass this kilogram dock. You observe the shuttle approaching the space station with the speed. Okay, now so make it m2 v2. After docking, the space station has increased this much. So that's the space shuttle now increased after docking. So V2A afterwards is actually V2A, yep, or VA, okay, because afterwards the whole thing is 0.098 meters per second increase. Okay, now show that the mass of the space station is this much. Okay, now then we need to walk down. Find out. Then we need to write down all the masses. Okay, now it's a collision. Okay, now we need to find some information. So conservation of momentum. Momentum before will be the same as momentum afterwards. Okay, then let's have a look what's the momentum before. Okay. Now floating in space. Okay. Now okay. So initially assume the space station has a mass of m. Okay. And for the mass of station, okay, and times the initial velocity, which is v1, name it m1, okay, plus the momentum of the space shuttle, which is m2 v2. Okay. Afterwards, okay, because they join together, m1 plus m2, okay, times v afterwards. Okay, so then we put down all the values. So m1 v1 will be 0 because v1 is 0 plus m2 v2, 6000 times 5 equals to m1 plus 6000 times 0 0.098. Okay, then we do the math. 30,000 equals to m1 plus you need to use a calculator. Okay, let's do it now. So 30,000 divided by 0.098 306122. 6122. Yep. Equals to M1 plus 6000. Now M1 must be 300122. Okay. Now have a look at the question. Three significant figures. Okay. Three significant figures. So it's going to be 3.00 times 10 power of 1, 2, 3, 4, 5 kilogram. Okay. Now proved, which is the same as this. Oh, actually we should use one significant figure here. Yeah, but it doesn't really matter in this case. Now, okay, now let's do the next question. Okay. Okay, what's happening here? Okay, an object initially at rest, so your way initially before will be 0. Okay, explode into two objects, two fragments. One part, mass 1. Okay. Now, with the speed, okay, this. Okay, remember this afterwards. So I label it. You can label it anything. Okay. Now I label it V1A. Okay. The other part, M2, moves at speed of V. Okay. What is V? So again, momentum before will be momentum afterwards. Total momentum. So initially at rest. Okay. So I have initially at rest. So M1 plus M2 is initially at rest, which is VB. Okay. Afterwards, M1 times V1A plus M2 times V1. V. Okay, it's just V. It's labeled here. Okay. Write down the number. Okay, here will be 0 because initially VB will be 0, so 0 times anything will be 0. Okay. V1, 2 times 6 plus 3V. Okay, now I have minus 12 equals to 3V. Okay, now V will be minus 4 meters per second. Okay, minus 4 meters per second means it moves opposite. Okay, opposite to the direction of M1. Okay, now M1 moves away, so the answer should be, okay, so V should be equals to 4 meters per second towards, okay, towards okay, sorry, actually what I can write down is it's 4 meters away, opposite direction to mass 1, okay, which is this. Okay, now down. Let's do this question here. Okay, now a frictionless trolley. Okay, M1 moves left, right. This is left. So if we make to the right positive when moving at left, so V1 before will be minus 4 meters per second. Okay. Now a blob of putty is thrown on the trolley and strikes it head on. Okay. The puppy sticks to the front of the trolley. The combined system of trolley plus the puppy continues to move left. So V afterwards will be minus 3.8 meters per second. Okay. In this particular question, the minus sign doesn't play much. Okay. But just remember, well, but you don't, because they all move to the left. So I don't, but just as a habit, I still put a minus sign there. Okay. What is the change in momentum of the party? The change in momentum will be momentum of the party. Okay, will be the momentum of the party after take away the momentum of the party before. Okay, so after, now we need to find, okay, step 1, we need to find the mass of the party first. This is a trick question, okay, because I have no idea what's the mass of the party. Okay. However, we should be able to find it from, this part is the party. Let's write down the mass of the party will be M2. Okay. So M2 we after take away M2 times 0, because initially it's thrown, so initially it should be 0. Okay, now we need to find M2. So let's find M2 from the conservation of momentum. P before, okay, total, just to distinguish from here, equals to total P afterwards. Okay. The momentum before will be M1 V1B plus M2 times 0, because the initial velocity will be 0, okay, for the party. Okay. Now afterwards, so they together M1 plus M2 times 3.8, okay, VA. So put down the values, 3.5 times 4 plus 0 equals to M2 plus 3.5 times 3.8. Okay. Now again we need to use calculators, so that's 14 equals to M2 plus 3.5. Well, just do the math there. Okay. Now I just do it like this. You don't have to do that. Okay. It is always good to use a calculator to find out the value, but I just do it so I don't have to use a calculator right now. So what's happening is you type this in your calculator, you have M2. Okay. Then we put M2 here. Sorry, if you put a minus sign, sorry I forgot the minus sign there, but if in this question it doesn't really matter. Okay, because it will be minus number will be the same. Okay, now if you do it here, your VA, basically your M2, if you find the value of M2 times minus 3.8, okay, minus 0, then you should have an answer which is a minus value. Okay, so remember the unit, Newton seconds or kilogram meter per second. Okay, now that will be good. Okay, but once, just remember, important thing in this is, okay, always label which direction is positive. Okay, in physics. Otherwise, the minus sign or the positive sign can make a difference. So if you label it, you are saved. Okay?